Okay, what we're going to talk about today is integration by substitution. And so this is for integrals that we can't integrate otherwise, or we don't see maybe necessarily real quickly. So for example, if I asked you to integrate this, and this is not a very easy one to integrate, but what you should notice from this is that if you look at this term right here, that it is actually if you take the derivative of that we actually get this term. And so that's what we're going to be looking for when we talk about integration by substitution. So what we're going to say is we're going to let u equal x cubed plus 2x. So then if we integrate this, we would get that du is equal to 3x squared plus 2 dx. Okay, and so what this allows us to do is it allows us to take our integral, substitute u in place of x cubed plus 2x, and then substitute du in the place of 3x squared plus 2. Now this becomes an integral that we can integrate very easily, so that this becomes 2/3 u to the 3/2 plus c, and then all we have to do is resubstitute back in our value of u, and so you would get that this equals 2/3 x cubed plus 2x to the 3/2, and then plus c. And that would be your final answer. Okay, so let's try another one. If we do another problem, let's say that we have this. Let's say we have the integral of x e to the 1 minus x squared, okay, dx. So what we're going to look at here is we're going to try and substitute in for the one of the higher degree. And so the one of the higher degree is u equals 1 minus x squared. And so when we take the derivative of this, we get du is equal to negative 2x dx. Now the problem with this is that in this function, I don't have a negative 2x dx. But what I do have is I have an x, okay, and then I also have a dx. So from both of those, what I can do is I can take this equation for the du, and I can divide it by negative 2, so that I would get du over negative 2 equals x dx. This allows us to now substitute that in the equation, so that now the equation would be the integral of e to the u, because our u was 1 minus x squared, and then we would have du, okay, divided by negative 2. That would substitute in for the x dx. So we would simplify this down to where we'd have negative 1/2 e to the u du. Well, now when we integrate this, it just becomes negative 1/2 e to the u plus c, and we substitute back in for u, we'd get negative 1/2 e to the 1 minus x squared plus c would be our final answer. Okay, one more. Let's say that we had this function. We said integrate cosine cubed x sine x dx. Okay, when you get something like this, what you want to substitute in for is the trig function that's inside the power, whatever the power might be. And so for this, we would say that u is equal to cosine of x. That means that du is equal to negative sine x dx. So when we substitute in for this, we would get, hey! So what we would get from this is that we would take and we'd have our integral. We would take our u, and now it'd be cubed because that got substituted in for cosine. And then our du, the problem with it is that we don't have a negative sign. But if I change this and say it's negative du, then that would equal a positive sine x dx. So then I would replace the sine x dx with a negative du. So then if we simplify this, we would get u cubed, negative u cubed du. Well, then we integrate that, we would get negative 1/4 u to the 4th plus c. Okay, and then substitute back in our value of u, we get negative 1/4 cosine to the 4th x plus c as our final answer. Okay, so that's integration by substitution. If you have any questions, please ask me in class. Okay, thanks.